Hi friends, welcome to our channel Math and Math. So today we will be solving a problem on matrices, that is finding an eigenvalue of a matrix. So this question generally it is asked in Kset and Csir Net exam. So we will try to find the solution for this problem. So what is given? Suppose the matrix A is equal to a 3 cross 3 matrix is given. It has a certain complex number lambda not equal to 0 as an eigenvalue. Then which of the numbers must also be an eigenvalue of A? That has to be found. So here they have given us 4 options and they have stated us that lambda not equal to 0 is an eigenvalue. So let us find the solution to this problem, but we will not be using determinant of A minus lambda I equal to 0 and then find the eigenvalue. That method we will not use since it is a CSIR net question or and also a Kset exam question. So we will solve it in a different approach. Here we will be using two rules. The first rule is that if the sum of each row is equal to S, then S is an eigenvalue of the matrix A. Okay, so if the sum of each row of a matrix results in some constant, say S, then that S itself is an eigenvalue of the matrix A. This rule also applies to column. That is, if the sum of each column is equal to some constant, say V, then V is an eigenvalue of the matrix A. Okay. Now let us see the second rule. The second rule is that sum of eigenvalues is equal to trace of A. What is trace? Trace is nothing but the sum of the diagonal entries, main diagonal entries. That is nothing but the trace. So we will use these two rules and we will find the solution to this given problem. So what is the matrix given? Let A is equal to, let us check for rule 1. So this is the matrix, let us check for rule 1. Rule 1 is that sum of each row. So what is the sum of the first row? 40 minus 29 minus 11. So minus 29 minus 11 is minus 40. Minus 40 plus 40 is 0. Second row, minus 18 minus 12 is minus 30. Minus 30 plus 30 is 0 again. Third row, 26 plus 24 is 50. Minus 50 is 0. So here we are getting the sum of each row as 0. So this is the eigenvalue. This is an eigenvalue. Okay. What about sum of each column? Here if you see 40 minus 18 plus 26. This is 48. Okay. So here you get 48. Here minus 29 plus 30, 24. 54 minus 29, 25. So here itself the rule fails. Okay. So only the first rule, which is for row, that is satisfied. So therefore 0 is an eigenvalue. Fine. So now let 0, lambda 2 and lambda 3 be the eigenvalues of A. Okay, lambda 1 is 0, that is why we have taken 0, lambda 2 and lambda 3. Since we have 3 eigenvalues, okay, so we have taken 0, lambda 2 and lambda 3. So what is the second rule? Sum of the eigenvalues, that is 0 plus lambda 2 plus lambda 3 is equal to trace of the matrix A. What is trace? Trace is the sum of the diagonal entries. Okay, so this 40 plus 30 minus 50. So this is nothing but the trace of A. So 40 plus 30 minus 50. Lambda 2 plus lambda 3 is equal to 40 plus 30, 70, minus 50 is 20. So therefore, lambda 3 is equal to 20 minus lambda 2. So now, if lambda 2 is not equal to 0, then lambda 3, which is equal to 20 minus lambda 2, is an eigenvalue. But here, since instead of taking lambda 2, in the question they have just mentioned, if lambda not equal to 0 is an eigenvalue, then which of the following is an eigenvalue? So instead of lambda 2, if you take it as lambda, if lambda is not equal to 0, then 20 minus lambda is an eigenvalue. So what are the eigenvalues? 0, lambda, and 20 minus lambda. These are the eigenvalues of our matrix A. So which option is right? 20 minus lambda. That is option C is the correct answer. Okay. So 20 minus lambda, option C, 20 minus lambda is the correct answer, required answer. Okay. So therefore in exam, just use these two rules and find out the eigenvalues. Okay. Thank you.